Welcome back to Alignment Techniques and Consulting second series in the presentations on wheel alignment. We are currently at McCarthy Commercial based in Boksburg. I want to thank them for using their facilities to demonstrate the difference in alignment machines that we have here today. Today we're using the JOSM laser machine, and we're going to compare values using the JOSM cam aligner machine. Today I have with me Mr. Keith Phelps from Sumitomo Rubber, who has a couple of questions that he'd like answered, and hopefully we can answer all those questions. I'd like to introduce you to Keith Phelps again.
Hi, I'm Keith from Sumitomo Rubber. I'm basically on the training department and also the technical department. Today I've got some questions for Keith on alignment on the UD truck. As you can see, UD is one of our main suppliers that we do supply the Dunlop brand to. And I'm looking forward to going through this vehicle with Keith and the truck cam machine and the JOSM machine so that we can check the alignment correctly. So follow us today, as this is most important on a vehicle.
Okay. Keith, as you can see here, we've mounted these self-centering gauges. They get mounted on the furthest parts of the chassis, in other words, as far back as possible and as far forward as possible. Now these self-centering gauges, we have one over here. Okay, if you have a look at this button in the center here, these are the hangers. They hang off the chassis.
Okay, so just explain to me, you are referencing off the chassis rail when doing alignment now?
We're referencing off the center line over here.
Okay.
So wherever I hang this gauge on the chassis, if you have a look at that black button,
yes,
it stays in the center of the chassis.
Okay.
Okay, so it's referencing off the center line of the chassis.
Alright, so that would ultimately be your thrust line, which is moving the vehicle forward.
Yeah, it's your they call it the other square.
Okay, alright, so that makes perfectly good sense. So once you've mounted this gauge onto the rear of the vehicle, you are then going to reference from this gauge, you are going to reference the chassis and the front wheels as well.
We're going to do the complete vehicle, front and back.
Okay. I'm looking forward to this. Let's have a look at it and let's go into it in a little bit more in depth.
Okay, this is the rim clamp. I'm mounting it onto the rim.
Okay, so before we carry on, Keith, just explain to me how this clamp actually works. Why are you mounting it on the rim and for what reason? Why are we doing this?
Okay. The beauty about this product is that this spindle that you actually mount your camera or your laser onto,
yes,
is now picked up dead center of the rim.
Okay.
Okay, so there's no room for any error in the measurements here.
Okay.
Okay.
So theoretically, you are referencing all your alignment readings of the center of the stub axle of the vehicle.
That's right. That's right.
Okay. Now, what happens if we have alloy rims or aluminium rims?
Okay.
How are we going to do this?
All right. Okay. So all we do is you take the rim clamp off. You notice that this fits inside the rim.
Yes.
Okay?
Yes.
So now with an aluminium rim, we just turn this around and we mount it on the outside of the rim.
Okay, so now let's say hypothetically you've done this on an aluminium rim, you will still be referencing from the center of the stub axle, so your gauge will still be perfectly set on the wheel assembly.
That's correct, yes.
Now, just explain to me, what happens if you get bent or buckled rims?
Okay, what we do there is we perform a run-out compensation. Okay, that compensates for any deformities in the rim. You're actually going to see now when I aim the laser at the board in the front there,
yes,
and I turn the wheel, I spin the wheel, you'll see the laser is going to run.
Okay.
So the object of a run-out compensation is actually to get that laser to stand still.
Okay.
And we do that through a series of adjustments on the rim clamp.
Alright, so that would mean once you put your camera on there, you are going to align your camera perfectly with the target in the front of the vehicle so that you can get a good reading. Now, just explain to me something. With the aluminium setup on the aluminium rims, when you put the clamp on, do you guys have magnetic magnets where you can mount the gauge on?
We do have, JOSM does have magnetic adapters. Now, remember, as you said, aluminium is an alloy. It doesn't, it's non-magnetic. So aluminium doesn't stick magnets don't stick to aluminium.
Right.
So what the wheel adapter that JOSM actually has
Yes.
actually mounts onto the wheel nuts.
Okay.
Okay, and also once again it will pick up dead center of the axle.
Right.
Okay, and besides it being mounting on the wheel nuts,
Yes.
you still have to perform a run-out compensation to get ultimate accuracy and consistency in readings.
Okay, so this, once you've done this and you are going to do a radial run out on this specific axle, this will also tell you if there is a mechanical related problem on here or excessive wheel bearing play or worn wheel bearing that needs to be replaced.
Yeah. When you're doing alignment on a truck, all right, this is a brand new vehicle, so we know that everything is fine. But you have a pre-alignment check sheet that you actually go through, where you do your kingpins, you check wheel bearings and all that type of stuff. If you're battling with run-out compensation, trying to get the run-outs the laser to stand still,
Yes.
you've got a loose wheel bearing. So it tells you that you've got a loose wheel bearing.
All right.
So each axle has to get jacked up and the wheel has to get rotated, okay, in order to determine to get dead center. Basically, we're calibrating this rim clamp to the rim.
Okay.
That's what we do.
So, just theoretically speaking now, do you move your machines around on the vehicle once they are set up?
The only thing that gets moved is your rim clamps. Your self-centering gauges on the front and the back of the truck, they stay there the whole time. They don't get moved at all.
So you are basically doing run out on every wheel position
Every single rim position.
to pick up if there is a mechanical related problem
That's
on a
correct.
specific axle
correct.
on a vehicle.
That's correct. And even if you have an issue, say now there's a loose wheel bearing here, you have to, now you've performed run out, now you have to take the rim clamp off and you have to adjust the wheel bearing. If you remove this rim clamp,
Yes.
okay, and you put it back on the rim, you have to perform a run out again.
Okay.
That's not to say that the rim is deformed, but from one rim to the next,
Yes.
you mount your equipment differently and you need to compensate for that for accuracy.
Okay. So once you've done this, and I'm sure we're going to do a radial run out check on the vehicle so that we can show the people how it's actually done, because I have seen a few wheel alignment technicians that have not carried this type of check out, and only too often we put another alignment machine on this vehicle and we would get a different reading, and that is because this specific radial run out check has not been carried out correctly.
Correct. That's correct.
So theoretically speaking, in an indirect way, the alignment technician that is not doing this will have difficulty in setting the alignment.
That's correct. That's correct. Another advantage of doing a run-out compensation is obviously because you have to rotate the wheel.
Yes.
Okay, it actually means that the handbrake is off. There's no air in the system to lock the brakes.
Okay.
Okay, so when you're jacking the vehicle up, you're turning the wheel.
Right.
Now I've had it on occasions where guys actually haven't done the run-out compensation.
Yes.
And they've just put the equipment on and they've gone and they've adjusted the wheel alignment. And because they haven't jacked it up and done the run-out, turned the wheels, there was
Yes.
no air in the system. This particular vehicle was a trailer. And there was no air in the system.
Right.
And these guys were adjusting the alignment.
Right.
So now obviously, the minute that vehicle started moving, the axles all jumped out of alignment.
Yes. So theoretically speaking, from word go, this trailer axle alignment was out of specification before it even left the yard.
That's correct. In fact, the client actually phoned me and told me his vehicle can't get through the toll gates. And that's just because the alignment, because of the correct procedures that we followed.
Okay, so let's carry out these measures and let's show the folks how we do this.
Okay?
So you're mounting your clamp now, you're mounting it on the edge of the rim lip,
That's right.
all right, and now you've tightened it. What is the next step now?
Okay. Now, obviously, the axle has been raised. Okay, you can see the wheel is going to turn.
Right, and the brakes are
The
off.
brakes are off.
Right,
Yeah. Always, alignment can only be adjusted if there's no air in the system or the brakes are off.
right, okay, and that would obviously be because of resistance
That's
and
correct.
the
That's
other
correct.
drag that you could get on wheel bearings that are
That's
worn,
correct.
etc.
That's correct.
Right, okay,
Okay. As I mentioned before, we're using the laser AM system. It's a mechanical system. It works with the laser. Okay. The beauty about this product is if you have the laser AM system, you can see I'm actually going to put this laser. This rim clamp actually belongs to the Josam cam aligner system.
Right.
Okay. But now I'm fitting the laser, so now I can bring the camera. And it fits the same wheel adapter.
Okay, so you don't have to change it.
You don't have to change it, no. Everything, you can get the upgrade from this system to the camera system. So you don't have to go and buy a complete new system. You just get the upgrade.
Okay.
There's an upgrade version.
Right. Okay.
Okay. The laser and the camera, we can calibrate them right here on the spot. So what we do is, you check the calibration.
Okay.
You see it locates in that groove there. Yeah.
All right. I see there's a slot there
that's
where the nut actually screws into the slot.
That's correct.
And that will only help
You see
for
there it
more
locates?
security.
That's it, there it locates, so it can't move around.
Okay.
So
Right.
now we want to check the calibration on the laser. Okay, so now what I'm going to do is, to check the calibration, I take the laser off, I turn it upside down, and you can see, it's perfectly calibrated, it stays on 100.
Okay, and that is just one of the three checks on the laser camera.
Yes.
So you put it the correct way, and then you remove it and you turn it upside down to ensure that your laser is 100% on your target
Stays
there,
on the same target.
and it stays on the same value.
That's correct, yeah.
Once that is completed, what does that mean now?
Okay, that means that your laser's been calibrated, so your values are all going to be 100% accurate.
Okay, so you are referencing now against your target there with a laser that is 100% calibrated now to your target.
That's correct.
Right, let's
So
carry on.
now we're happy with the calibration. The calibration's been done.
Okay.
Okay, so what we're going to do here now is, Keith, we're going to aim the laser at the board. We haven't done a run-out compensation. In other words, we haven't calibrated the rim clamp to the rim. Okay? Now I want to see you. John over here is going to turn the wheel while aiming the laser at the board.
Alright, so we're going to reference off your front target,
Yes.
and we are now going to do a radial run-out check to align the gauge with the center of the axis.
That's correct. We're going to compensate for any deformities in the rim.
Right.
Okay. So let's go and have a look at the laser here. While John spins the wheel, you can aim at the laser there, Peter. Okay, so John's spinning the wheel. Look how much that laser is actually moving.
Wow, so there is a lot of movement
There's a lot
there
of
now.
movement. Look, what? It's going to come back now. Can you see?
Alright, so
That's at least about 20 millimeters that it's actually moving.
okay, so now what we need to do is we need to set that gauge up that it is 100% in line with your stub axle of the vehicle so that we can get your reading to be 100%.
That's
clear.
correct. That's correct. Now I want to show you something else. Okay, now when you're doing a run-out compensation, your furthest point is always your most accurate point. So you can't do a run-out on the back board because now we haven't changed this rim clamp at all. So if I aim this laser at the back here, okay, and I'll spin it, see the laser standing still.
Yes,
It's not moving.
correct.
Okay. So you always use your furthest point, which is your most accurate.
Right.
Okay.
So we're gonna set this up now with your furthest
furthest
target.
point. That's
so
correct.
that we can get this gauge 100% set on.
That's correct.
Right,
Okay.
let's do that.
So I'm going to continue with the run out now.
So now you're aiming the laser at the target now.
Yes.
You're going to reference. And now you're going to rotate the wheel
I'm
again.
going to rotate the wheel. It rotates on a, you take your first reference, you rotate the wheel 180, half a turn,
Right.
180 degrees, you make your adjustments.
Right.
Okay. Go back 180, check that the laser is standing still.
Okay, so you're constantly doing a check of 180 degrees to ensure that it's center.
That's right. Yeah.
Right.
Okay.
Let's do that
So
and check
I
that.
just want to see what the value is here. Okay, so the first value we've obtained is 110.
Right.
Okay, so now I'm turning 180 degrees, half a turn.
Right.
And there you can see it's 95.
Okay.
Okay, so now we adjust it.
So now you're adjusting it to bring it back to the original setting that you had.
No, we haven't done any settings yet. We're just calibrating this rim as it stands here
Okay,
now.
so
we're just calibrating
Right.
this rim clamp to the rim.
Okay,
Okay.
100%.
So now I've turned it all 180 degrees.
Right.
So now I want to check. Now you see it's on 100 there.
Yes.
Okay, so I'm going to just double check. Turn it to the front again. Okay, it's slightly off.
Right.
Right, so we go back.
So you literally doing every check and measure that you can to ensure that your reading is 100% on your target.
So this laser, when I'm finished, the laser will stand still when you turn the wheel.
100%.
Okay, so I've adjusted the slight adjustment there. Let's do it. Half a turn again.
I see.
Okay.
Your reading now is 100%.
That's correct. Okay, so now I've adjusted, I've been working with a white button here. So now I just do a quarter turn to the black one.
And you're going
Now adjust it onto the same value that it was before.
right. So now you've done all the checks and measures now. Your laser is now staying constantly on 100 there. That means that this clamp is now aligned with the rim and with the stub axle of the vehicle.
That's correct.
So once this has been done, you would then obviously move your camera and your clamp to the next wheel.
Okay. I've only been able to get one laser today, so I'm going to be working with one laser.
Right.
Okay. So now what I've done on this rim here,
Yes.
I have to do on that rim.
Okay, so what you're doing to the one side of the vehicle, you have to do to the other side of the vehicle.
That's correct.
Right, let's go.
So I just want to turn this wheel and check the laser. Can you see the laser standing still now?
Standing dead still,
Can
right?
you see that?
Yes. Okay, so we've done the right side of the vehicle now. Keith has done the radial run-out checks, and we're quite happy that that camera and laser is lined up with the target on the right-hand side. And now we're going to do the left-hand side of the vehicle to ensure that our readings stay consistent with the target in the front. So Keith's going to carry out this quick radial run-out check, and then we're going to continue with the alignment. So you're checking it again and you're making sure that the values are all the same.
That's correct.
So slight minor adjustments, and then we will get the right hand side reading exactly the same as the left hand side.
That's correct.
And I must add, I'm quite impressed that it only takes a couple of minutes to do this check. And I must say that this is one of the few times that I've seen people or you actually do a radial run-out check like this. Because only too often I'm standing at a vehicle where alignment's being carried out, and I don't see the wheel or the wheel alignment technician doing this type of check.
Yes, that's why I said in the previous presentation, Keith, alignments is a very grey area, you know. Some people can perform alignments with a tape measure better than a person with the right equipment. It depends on the person's attitude, you know. And that's why I'm so honored to be able to be associated with the Josam product, because it eliminates every type of guesswork that you can get.
So all the guesswork is taken out.
It's taken out. It's taken out. We don't have to put any input, any information. We don't have to feed the information to the computer. The computer calculates everything for itself. So in other words, we don't put in widths of chassis or axle offsets or anything. We go straight ahead and we perform line. It's simple and it's basic and it works.
And it's 100%
100% accurate.
Right, so once you happy with the run out check now? We're gonna carry on with the alignment.
Now we're going to check what the axle alignment looks like now.
Right. Let's
Alright, so here we have the Josim, the Laser AM mechanical report sheet, and you can see all the vehicle details here, the customer's details, the mechanic that's working on the vehicle, all those details get filled in. So now we're finished with the run out compensation. We're actually going to go and measure how the axle is lying with reference to the center line of the chassis, and that we'll do with a calculator.
Okay, so Keith, just explain to me now, how are we going to do this? How are we going to calculate this whole...
Okay, so everything is worked out in distance.
Right.
We calculate the distance between the boards,
Right?
and let me just get the laser quickly and it'll make more sense.
Okay.
Put the laser on here. Run out has been done.
Right?
Put the laser on.
Okay.
Okay, so now I want to see what value that is over there.
Right? So we're going to check the target here now. And sitting on 100.
It's actually, so what happens is this switch from 0, 10, 20, 30, 40, 50,
Right?
60, 70, 80, 90, 100.
Right.
In between there
Yes.
is decimals of 2.
Okay.
Okay, so we would say that's on 98.
Right?
Okay.
So we're then going to take...
So we take the value at the back now. And that's about 96.
Okay, so 98 in the front and
96.
96 in the rear.
That's correct. Now we go to the report sheet.
So now you're going to fill your report sheet in. And
Okay. So A would be the front target.
okay,
Okay, 98, right?
right?
98
Yes,
and 96.
right.
Okay, the difference is 2.
Yes,
Okay, so the distance between the scales is 7 meters.
yes,
You can see their distance in meters,
Right.
7 meters. Okay.
Yes.
Now I'm going to take the values on the other side.
okay. So we've got the values now for the right hand side. So we're going to do exactly the same now for the left hand side to check that these values are the same.
They won't be the same, but so it's going to calculate the position of the axle in
Right.
the center line. So on your left and right hand sides, you will never get the same values. They do differ slightly.
Okay.
Okay.
So what is the tolerance that one is allowed between the difference in gain?
It's difficult to say. There is no real tolerance on the values obtained.
Okay.
Your end result, your actual out of square, the actual out of square,
Yes.
that is your end result. That's where the tolerance is coming to play.
Okay. So
Okay.
let's check this one now and let's have a look.
Okay, so here we've got 85.
Right?
And 95.
Right.
Okay.
So 85 front, 95 rear. Right. So let's write it down on the form. So we're going back to this side now.
So it's 85 front,
And 95 rear.
95 rear.
And we're talking the same floor length and distance.
Yes. Okay. So now that in maths, okay, when you're subtracting, your value on top is always going to be greater than the value on the bottom.
Right.
Okay. But in this case here, you see the value in the top is
Less.
Is less.
Yes.
So that is automatically a minus.
Right.
Okay. So you can put a minus there.
Right.
Okay. So the difference between 85 and 95 is obviously 10.
Okay.
Okay.
Okay, so we've got 85 on top.
85 on top minus 95.
Right. That will give
Gives you
us
10.
10.
Okay.
So we minus 10.
In the minus 10, yeah.
Right.
Okay. So now we need to divide that by the distance of the targets.
Right.
Okay.
Which is 7.
Which is 7. Divided by 7 gives you 1.4 minus. Okay. So yeah, you'll see a C5.
Yes.
There's C5.
Right.
Okay. So there we will put in, it's minus
Right.
1.4.
Okay.
Okay. Now the other side,
Right. We've got 98.
98 minus 96 gives you 2.
2.
Divided by 7 gives you 0.2.
Okay.
Okay, so you'll see there C6,
Right.
there's C6.
Okay.
Okay? So there you will write in 0.2.
Right.
Okay. So now we want to work out the total tow of the vehicle.
Right.
So we'll subtract 1.4
Right.
from
0.
0.2, which gives us 1.2.
Right.
Okay. But you see the minus is the bigger value. So this axle is running tow out 1.2.
Okay, which is not too bad.
No.
It's well
perfect.
within
It's
within
perfect, yeah.
specification.
Theoretically, people prefer to have your drive axles running a little bit of tow out because theoretically they say when the truck drives, it pulls the axles in. But you're not going to always get the perfect, ideal circumstances.
Situation.
Yeah. So they're usually within a 2 millimeter tolerance on the total tow.
So this here is well within the specification of the OE manufacturer and of the wheel alignment
Yes.
specifications.
Okay. Correct. But now remember, we've only worked out the total tow.
Right.
Okay. So this is running tow out, slightly tow out, 1.2 millimeters tow
Yes.
out. Now we want to find out what the position of the axle is with reference to the center line of the chassis.
Right.
Okay.
So how do we do that?
Okay. So we take 1.4, and you add 0.2, and you divide the 2. Divide it by 2. The axle is at 0.8 millimeters
Wow.
positive.
So that is virtually nothing.
That's almost 100% straight ahead.
wow.
Okay.
That's a good reading.
0.8. Now what we're going to do is hopefully, I don't work with this machine often enough, but now once we've completed this alignment, we're going to actually stick the camera liner on and
Right.
see how close we come to the values
Okay.
that the values I've obtained here.
Right. So
Okay.
what are we going to do next?
Okay, so now we know that this axle's fine.
Right.
So now we move our equipment to the next
To
axle.
the next axle.
That's correct. We follow the same procedure once again.
Right. Okay. Right. So as you can see, Keith has done the rear axle. We've done all the checks and measures, and we're quite happy that this axle is running parallel to the chassis rail and that the thrust line is all in order. So what we're going to do is we're going to go to the first drive axle now, and we're going to do exactly the same checks and measures to ensure that this axle is running 100% parallel to the thrust line and to the chassis rail of the vehicle.
Okay, I'm going to go ahead and do it. Once again, you can see I'm using the featherless target. It's more accurate.
Okay?
Okay. It's a bit easier to see when it's closer. Rotate the wheel 180.
Right, so now we're going to check it again. Wow, it's got quite a bit of
Quite a
run.
bit, eh?
Yes.
Now, can you see from one room to the next?
How it differs.
Yes. I haven't really adjusted anything yet. But if you'd like to point at the laser there, I'm going to spin the wheel and just see before I've even done runner. Now it's moving from one room to the next. Can you see it? Can you see why run-out compensation is so important? Why you have to calibrate the rim clamp to the rim so you get accurate, consistent readings.
I must say, it's actually quite scary to see the difference between the rear axle and the front drive axle, how the run-out actually differs on the target.
That's why you have to do runner.
Okay.
And on every single rim as well that you work on, you must do runner.
Right, so let's get this one aligned and let's have a look and see how accurate we can get this one. So now you've done it 180 degrees again, and now you're going to make your adjustment.
Correct. So I'm just going to double check it. I'm going to go back to the first reference.
Right, so we're double checking again. No harm in
it's on
checking too much.
That's it, it's on 100 now.
Right, and we're going to check it again.
It's important that this is done properly. If it's not done properly, your values, you can imagine for yourself, aren't going to make any sense. Okay, so we've got 95 there. I'm going to check 180 again. Happy with that?
Yep. So now once again, we're going to check it and see.
Now all I do is I take the black one and I adjust it.
Right, so
That's
you
the runner.
happy now? This is 100%
calibrated to the rim.
Calibrated to the rim.
That's
So now we're going to go and we're going to do the other side of
That's
the vehicle.
correct. Yeah.
We're on the other side of the vehicle now, and as you can see, Keith is going to do the radial run-out check here. We're happy with the values that we had on the left-hand side, but as Keith says, this has to be done to ensure that the radial run-out checks are 100% accurate and that your clamp is correctly mounted on the rim. And we're going to do the check now and just see you turning it once again, you're checking it at 180 degrees.
That's correct, yeah.
To enable that laser pointer to get to the correct value.
That's right. Some guys can do this, they work with it regularly, so it doesn't take them long to do the run out. They can do it much quicker than I do. As I said, I don't work with this machine every day. It's going to be interesting to see how close my calculations come to the computer. Okay, run out complete.
Right, so you've done the run out now, you've checked. So we've basically done all the drive axles. We're now happy that the radial run out has been checked on the furthest target, and we are going to just work out now the values quickly on this axle, and that'll give us a very good idea as to what's happening on the drive axles.
That's correct.
So Keith, we've done the rear axles now. We're happy that they're all within tolerance and there's very little that has to be done to the rear axles. What we're going to do now is we're going to check run out on the steer axles now. Just explain to me now how we're going to go about this now.
Okay, the procedure is the same, but the problem is, because the steering axle turns, it's important not to apply pressure on the side of the wheel. You basically got to roll the wheel, because if you apply pressure, your laser's going to move and your run-out's not going to be correct.
So you could possibly end up with a wheel slightly turned if you're applying pressure to it.
That's correct.
So that's quite an important feature that one has to remember all the time. You cannot put pressure on this wheel while doing run-out checks on this vehicle.
Yeah.
Alright, so let's do the run-out and let's check it now. So we're doing the same procedure again. We're measuring with a laser to our furthest point, and we're going to do the 180 degree checks to ensure that we get the correct reading at the back.
That's correct.
So we're going 180 degrees now and we're checking it. And I see what you mean as it moves around, you actually getting it centered again on the stub axle of the vehicle.
That's correct. It automatically picks up the center of the axle, yeah.
Right. Okay, so we're going to check it now. Okay, so I see there is quite a bit of run out on this wheel position. So you are going to adjust the clamp now so that it is 100% lined up on the wheel position.
It's calibrated to the rim.
Okay, so your calibration now, you've done the checks and that now, and this is now calibrated.
That's calibrated to the rim.
Right, so now you're happy with this clamp is now calibrated to the rim now. Your readings are staying consistent there. And what we're going to do now is we're going to go and we're going to do the other side of the vehicle as well, so that we get the correct calibration.
I'm just going to do this one again quickly. Because of the distance and the light shining from the background, it actually affects your eye, so you can't get, you have to go closer to the board.
It's better to check once we're up against the board.
Correct.
Keith, just explain to me now. If you have wheel bearing play or kingpin play on this wheel position, would you still be able to carry on doing your checks here, or would you first have to tighten the wheel bearing or sort the kingpin out before you did alignment?
We never do any adjustments. If there are any worn components, we do not do adjustments. We'll take measurements. But first has to be repaired, and then we'll do the alignment. And your alignment always gets done. Your alignment is always your last check, whether it's chassis straightening, suspension component replacing. Your alignment is always the last step, especially in chassis straightening. Your alignment is going to tell you if your chassis is straight.
Right, so theoretically speaking, any wheel bearing play, any kingpin play, or any play on the suspension, whether it be leaf springs or worn shock absorbers, etc., you have to repair that first before you can continue in doing this check and continuing with the wheel alignment. So we've done the right side of the vehicle on the steer axle. We're happy with the values there. Now we've come to the left side of the vehicle and we're going to do exactly the same check as the right hand side. We've got to check the left hand side to get the run out values, and you see that this clamp is now 100% adjusted according to the number. Right, so let's do this one now. So I see once again you're referencing to your furthest target. Right, you get the values there. Seem to be pretty accurate now. Yeah. So we know that we're heading in the right direction. We're doing the 180-degree check again to ensure that everything is lined up with this clamp according to the rim and tire assembly.
Okay, run out is complete. Now, what we do is we put these non-friction plates under the wheels.
Okay, Keith, before we carry on, explain to me why it is so important to place a non-friction plate underneath the steer axle of a vehicle when doing alignment. Because only too often we find that when we are in field, we see wheel alignment technicians adjusting wheel alignment on the steer axle and no non-friction plates are being used. Why do we use these friction plates?
Okay, these non-friction plates, obviously, the name tells you everything. You can never adjust an alignment with a vehicle on the floor because it builds up resistance when you're adjusting it.
Okay, so your tread pattern, if you had to set alignment on a floor without the non-friction plate, your tread pattern of the tire can cause a lot of resistance when setting your toe settings on the vehicle.
That's absolutely correct.
So that is why it is imperative that you have to use a non-friction plate under the steer axle of the vehicle.
That's correct. And we've often found a case where people have only used one plate under a wheel. They only put one plate under a wheel and they go ahead and adjust it. That's not the right method. There's two non-friction plates for a purpose, one on each wheel.
Right, so once again, you can see two friction plates must be used and not one friction plate, as this will also affect your toe settings when the adjustments are being made. Okay, Keith, so we've now checked the radial runout on the left-hand side of the vehicle, and we're happy with the values that we found there. And what we're going to do now is we're going to check the toe out in turns, or the toe settings.
The toe settings.
The toe settings. Right, so what we're going to do now is we come back to the right-hand side of the vehicle, and we're going to start with this wheel position first because your steering box is on the right-hand side of the vehicle.
That's correct.
So what we're going to do is we're going to measure again, we're going to measure our furthest point, which is the target at the back, and then we're going to measure on the front target now and see that they are 100% correct.
That's right. So basically what we're going to do is on the right-hand side, we're going to get the values on the front board and the back board to be the same.
Okay.
And in order to do that, so we'll have a look now.
Okay, so now what you're doing is you're just going to check that that value is correct.
So we've got the 240 on the back.
Right, so
Okay.
240 on the back,
And the front, we've got 164.
160.
Okay. So now in order to get those values the same,
Yes.
we need to turn the wheel. Now you can understand why it's important to have non-friction plates. You can never do this with a vehicle on the floor. It has to be on non-friction plates.
Okay, that is just to make it easier to turn the steer axle
That's
of the
correct.
vehicle.
And when you're turning, you always look at your furthest target because that's the most accurate target there.
Right, so we're going to place the laser back on the back target.
Right, so
And
now-
we are now going to turn the wheel.
Turn the wheel. It's on 150 there,
Right,
and we've gone a little bit too far because we're on 180 here. Eh?
right, so then we go back.
So I'm going to put it on about 170 at the back.
Okay, so you're checking the back now that it's 170. And now we're going to check the front here.
Got to go a little bit more.
So back again to the back target again for accuracy.
180 there. We're gonna go 175.
Right, so rather check it again. Let's just make sure.
Okay, we've got 175 there,
Right, and now we are sitting on
175.
175.
Okay.
So this is now straight. In other words, your steering is now steering straight ahead.
That's correct, yeah. So now we've got this wheel straight, now we need to actually calculate what the toe is at. So now we're going to take the values on that side and we'll calculate what the total toe is at.
All right, so let's go. Let's take the camera off, and we're going to go and sort it out on the other side of the vehicle now.
Okay, according to my calculations on the front axle now, we're
Right.
running toe out 0.5 millimeters.
So 0.5 millimeters is well within
That's
specification.
within specification. Yes.
So then, in theoretically speaking, you would leave the alignment like it is. You wouldn't do any adjustments on it. Right.
Okay. Now, what we're going to do now is we've taken the values with the mechanical system. We've calculated. You've seen we've calculated the values out to the calculator.
Right.
Now we're going to stick the electronic system on,
Right.
and we're going to measure again and see what values we come up with.
So theoretically speaking, between the mechanical system and the laser system, the readings should be
Well,
probably 100%.
pretty close.
Pretty close, yeah. But it would still be within tolerance.
Yeah. It's still within tolerance. You must remember your computers are always more sophisticated
Yes.
and more accurate.
All right.
Okay, but let's see how accurate we are with the mechanical system.